Hello, hello. We are back and we are streaming. Hope everyone's having a great day today. Let's go ahead and let the Discord know that we are live. All right. Let's quickly come on, refresh here. Should come up with our stream in a second. Home. There we go. All right. Cool. Let's pull up chat here. Come on, load. There we go. All right, we got the chat loaded up here. Hello, hello, welcome back, everybody. I hope everyone's having a wonderful day so far. Today is Saturday, December 28th, 2024, and I'm going to be doing some Python studying. So, yesterday we left off completing a few of these exercises from the end of data structures and algorithms in Python. Um, so, hey, Ray313, how's it going? What's up? What's up? Appreciate you coming in. All right. So let's go ahead and do r 6.11 underscore key dot py. We'll move this guy in here. Three here. Go Control C, Control V. Cool. Pardon me. Pardon me. All right. Sarah, hey, welcome in. I appreciate you coming in and saying hello. Welcome back. Hey, ProDoc18, been watching some of your videos. I finally caught you live. How are you liking Python? I'm really liking it. I'm really enjoying the learning that we're doing so far. It's kind of all coming together here, a little by little, day by day, obviously. And so we're gonna hopefully keep grinding through these. I appreciate you coming, Doc18. Thanks so much for coming in. Okay, let's go ahead and let's try this problem. So give a simple adapter that implements our QADT while using the collections deck instance for storage. So we need to go from collections, import the deck, right? So we're gonna define a class called Q, or right class Q, right? And then when we initialize Q, we're going to take in object itself, and then that'll be it. And then we'll say that the self dot underscore data is equal to the deck, right? Class. Cool. So we have an initialization of a queue where like that. Cool. So that initializes the deck, right? So we're using an adapter that implements our QADT while using a collections.q, or deck, I mean. So we import deck, we're going to be using a queue here. So what are all of our things for a queue? So we have init, we have a length. I'm not exactly sure what this problem is pretty vague. So give a simple adapter that implements our QADT while using a collections deck instead for storage. So so now I'm going to ask the almighty orb for some help on this one because I'm honestly not really sure what it's asking us to now further implement here. To implement a simple adapter for a QADT, all right, using the collections deck, we create a wrapper class that defines the desired Q operations. The collections deck data structure is used for internal storage because it efficiently supports adding and removing elements from both ends. Okay, so we have some collections import. We import, and we have data as the queue. So we have an enqueue method. Okay, so let's just try to like do this without really going ahead. So we have a def enqueue method, which takes in self and some element, right? So this is going to self dot underscore data is equal to self underscore data is equal to no, we do this dot append the element, right? Yep, so that perfect, that appends. So now we need the dequeue method. So the def dequeue method right here, right, which is going to take in the instance itself. And then, so to dequeue a method, we need to say, and we have an element, right? No, actually, because the dequeue happens immediately at the, so we'll do self dot underscore data dot pop at index 0, right? So we'll pop the element off. Okay, so they say if, okay, so they put in a check here to determine if it's empty, right? So if self dot underscore is empty, right, we're going to raise index error and then give a thing here saying dequeue unsuccessful from an empty queue. Right, like so. Hey Christy, welcome in. I appreciate you stopping in today. How's it going? We're doing a little bit of an earlier stream today. I'm going to a basketball game tonight. My last night here visiting. Today's the last day I'm going to be visiting my folks. I'm heading back home tomorrow, catching a flight back. So tomorrow we will be back in our normal setup. So yes. So the pop left function happens. Okay, so we return self.data pop left. So there's this pop left method within this deck. So this just pops the left side. Okay, so then we need a front. So def front and takes in self. So this determines the item at the front of the queue. So if empty, okay, so if self dot underscore is empty, we're going to raise index error, or yeah, say front from an empty queue, index error, and then say front from an empty queue. Okay, else we're going to return self.index self at index 0. No, self dot underscore data at index 0, right? Yeah, return self data index 0. Now we do is empty. So def is empty with the instance itself. And say if not self, or if not self dot underscore data, right? What do they return? Oh, they return the length. So they return just the length of 0. Self dot underscore data is equal to 0, like so. Okay, and then they have a size function which gives the length of the data. Def size of self so this one's interesting. So return length of data is equal to 0 if it's empty. So okay, yeah, that would work as well. So then the size is just the length of the data. Hey, Madi, I appreciate you coming in. Welcome. That's a new name I haven't read on the chat before, so I appreciate you coming in. At least I think so. We have had quite a few people pop into chat, so if I got that wrong, I really apologize, but I really appreciate you coming in. Script Serpent, welcome back. Hello, Angela Lopez, welcome back. How you guys doing today? Okay, so just like that. I think that that is the answer to this problem. This one was a little bit harder. Like I didn't know where to go from here. Okay, so this is kind of what it needed. They want us to create the class. Okay, let's move on. 6 or R 6.12 underscore key dot pi. 1, 2, 3. Good to see you grinding Python. Awesome. Yes, I appreciate you coming in here. How are you guys doing today? How are you guys doing in your learning? Where are you guys at in your Python learning? Are you guys CS majors? Are you guys teaching yourself? What's going on with you guys? I'd love to hear. Okay. So we have this now. So let's see here. Okay, so these ones are fun. What values are returned during the following sequence of a deck ADT operations on an initially empty deck? So here we go. We have a deck equals empty, right? In our first one, we're going to first for So let's go back up to the deck. Okay, so the first is just accesses the first element. The last just accesses the last element. So this is just no operations are happening here. So this remains with the deck equals to empty here. If we do a add last, right, for 8, this becomes deck is equal to 8. Add last 9. So I'm going to, let's go down here, add last for 9. So our deck is now going to look like this, is equal to a list of 8 and 9. First, add last, add first 5. So here, add first on 5. Our deck would look like this, and 5 would be appended at the beginning. Um, add first 5. Back. What does back do? Back. Um, back. All right, we got some chats here. I took down a website for a few hours yesterday because someone was exposed. Oh, awesome. That sounds like a good way to do that then. Um, Pro Doc, currently solo learning the Python crash course book that I had collecting thus. Oh, that's awesome. Yeah, I did a live read through on the channel in my past streams of all of Python crash course part 1, and I've completed a lot of the I completed all of the try it yourself problems live on stream as well. So if you want to reference that, feel free. I also am posting the solutions to those answers as well. Back should get back of the queue, I guess. But we have a last here. So last, right? So add first, add last, add first, back, delete first, delete last, add last, first, last, add last, delete first, delete first. We have some chats here. Madi says, I'm a new grad working full time as a software engineer. I'm studying my SQL currently. Oh, awesome. That's great that we have a software engineer here. You could definitely provide me the help I need with this learning, so I appreciate your help. Thank you so much for coming in here, Madi. Welcome. Angela says, teaching myself. Yeah, like usual, we're one and the same, you and me. Um, hey, Jeremy, welcome in. It's good to hear from you. How you doing today? How's it going? How's school going? Okay, let's look up the back function method for a queue or for a deck. In Python's collections deck, the last element can be accessed using the -1 index. If you include a back method for a queue ADT implemented using a deck, it would return the last element without removing it. Okay, so it's just as similar to last, I guess, because we're using a deck ADT to resemble a queue. So if we were to say we did, last one was add first 5. So our back is going to just oh, this is add first 4. Whoops. So this is add first 4. So we have to put a 4 into here like so. 4 goes here, and then 4 goes here. Okay, like that. So back would just reference the 9 value. So our deck doesn't change here with the back call. Delete first. Delete first. This will take our deck and remove the 5 out of it. Right? Now we delete last. Which will take our deck and we'll take the 9 out. Okay. Add last at 7. We'll take our deck. It'll have a 4, 8, and 7. We have another first call, so this will be a reference to the first. So this is a first call. The deck does not change on this call. So Mondi says it's last, but it's just a peek at last. But isn't our last function just a peek at last as well? We just access that element, but we're not removing it from the list. We're just accessing it. So isn't this technically a peek as well on first and last? I think the whole back and front or whatever is just because we're using a deck ADT for a queue. So they both have the same meaning. I think that's what it's trying to convey. What do you think? Okay, now we have a last call, which doesn't do anything to our deck. We have an add last 6, which will take and add a 6 to the end of the deck. We have a delete first and a delete first. And this will take this deck and delete the 4 out of it. And then if we have another delete first, call, this will take our deck and delete the 8 out of it. Like so. So we have an empty deck. We have an add 1, 2, 3, 4, 5, 6, 6 adds. And we have how many deletes? 1, 2, 3, 4. So we should have 2 remaining values. Exactly. Cool. Awesome. This was the answer to 612. Sweet. That one wasn't too bad. Definitely. Let's keep going here. R6.13 underscore key dot pi. All right. And this is a little bit of an earlier stream than I typically do for the past relating to the past couple days. I am going to a basketball game tonight. It's my last night on vacation here, visiting my parents for the holiday break over Christmas. I'm going back tonight or tomorrow back home, and so we'll be in our normal setup tomorrow, and we'll do a normal 2.5 hour, 3.5 hour to 3.5 hour stream tomorrow. So we'll have a normal stream tomorrow where we'll really we'll actually do the learning and then actually work on our projects as well in the same stream. So look forward to that one tomorrow. We'll just have one more day of the shortened format, and then just this one's a little bit earlier because I'm going to an event tonight. So I appreciate you guys being flexible here, learning with me. I just wanted to, at least hop on for a little bit and keep the streak alive and keep these concepts, going in my mind. I find that once you take a couple days off, or if you do take a couple days off, it's really easy for these concepts to kind of just drift out and be forgotten. So we're really, sticking to the schedule here and, trying our best to, prove this whole thing to be, a worthwhile, that we're really learning this. So, okay, here we go. Suppose you have a deck D containing the numbers 1, 2, 3, 4, 5, 6, 7, and 8. Okay, we have a deck D, which equals to a list of 1, 2, 3, 4, 5, 6, 7, and 8, right? In this order. Suppose further that you have an initially empty Q. Okay, we have a Q here, which is empty. Give a code fragment that uses only D and Q and no other variables and results in D. Give a code fragment that uses only D and Q and no other variables and results in D, the deck storing the elements in the order 1, 2, 3, 4, 5, 6, 7, 8. Is this a typo? Is this supposed to be a Q? Is this a typo? So we're supposed to write a code fragment that only uses the deck and the Q variables and results in D, the deck storing elements in the order that we already have above. Yeah, I think it's supposed to be results in Q storing the elements in that order. What do you guys think? Okay. So we need to do so this would be, I'll do _1, _2, def swap, right? And we're going to take in a dec and a q. So if we're going to make this function, we're going to say while length, while, should we import from collections? Let's import q. And import dec. So is there no q here? Collections import q. The collection module in Python does not have a class named q. Instead, the q.q class is part of a q module designed for the thread say. First, the collection module provides a dec class and general purpose. Okay, so we have to use the dec class. Okay, so we have a dec. While you provide some q and then you have some dec, right? Gotcha, Legendowski, thanks so much. Yeah, there's no q in Python, there's only a dec. Okay, so if we want to say while the dec of D, right? We're going to convert dec to a D to a dec, and then we'll say while there's values in there, we need to pop each one off. So the pop will happen. We need to remove first, pop left, and then append. So we'll need to do so we actually need to convert. Let's do dec D is equal to the dec of D, right? So now we'll save D as a dec rather than have it here. So while we have values in D, we're going to D.pop left, right? So that's going to remove all the values on the left, and we're going to capture that value and do dot append. That'll be captured, and then we'll say q.append, like so. And so while D else, okay, and then we're going to return q. So while D else can we use an else statement here and say like else or elif? So while there's values in D, we'll do these append. Else there's no values, we're going to return right. If I say else here, no, because once D gets empty, it will raise that index error. So we don't want to do that actually. So let's just return the Q here, and then let's just try to see what this does. Oh, come on. Oops. Hey Mahan, welcome back. It's great to hear from you. I appreciate you coming in. Yeah, we're doing a little bit of an earlier stream than normal. I'm going to a basketball game tonight, so I am a little bit tied up this evening, and I wanted to make sure I did some studying for today and kept the streak alive. So we hopped on a little bit earlier. So I appreciate you joining me today. Welcome. So let's print swap of D1 and Q1. Or Q1, right? And what do we get here? Boom. All right, cool. So that does that. Now, is the pop left super efficient? No, right? I don't think so because we have to physically pop this value and then shrink the list every single time for this pop. So I don't think that this is super effective, but we only are allowed to use these two variables. We're not allowed to create another queue and then kind of swap the pops onto the queue and then offload them onto or make another deck and then we can't make a third data structure to kind of have that like in that what is it alternating popping and appending going on. So how do we feel about this, you guys? Right, I think that this works, right? This gives us our queue when queue is initially empty. And then let's also let's return the deck here and see what we get. Right, the deck is just an empty deck. Perfect. So that is successfully handling all of those. Um, it's successfully popping off all the elements from the deck and appending them onto that one. I'm assuming that this has a typo because it says, suppose that you have a deck D containing these numbers in this order. Suppose further that you have initially empty Q. Give a code fragment that uses only D and Q and results in D storing the elements in the same order. Well, this is the same thing. So I'm pretty sure that this is a typo and supposed to say Q storing the elements in this order. So let's go ahead and let's go here and say, is there a typo in this question? Are we supposed to be appending to the Q variable? The question appears to be correctly stated. The task is to rearrange the elements D so that it ends up as 1, 2, 3, 4, 5, 6, 7, 8 using only the D. This involves temporary removing elements from D and Q to achieve the desired. The Q is initially empty, allows for temporary storage and rearrangement of elements. We don't append new elements instead. So this is what I did. Your code takes deck and moves all elements to list queue using pop left and append. While this code is valid, it does not address this specific problem of rearranging the elements in D to achieve the desired order. But it says that it's in this order. Suppose you have a deck D that is in this order. Suppose further you have initially empty Q. Give a code fragment that only uses D and Q and no other variables and result in D storing the elements in the order. Okay, so we're supposed to start with an empty Q. Okay, maybe we're supposed to do this actually. Maybe we're not supposed to swap these elements. Maybe we're supposed to say that deck D, we're going to say, given some deck D, sorry if you hear the barking. My mom's dogs are yappers. Sorry guys, please bear with me. They'll stop in just a second. Oh, my bad. Okay, I didn't see that. So this deck has the 5 and the 4 mixed up. Thank you, Aaron. I appreciate that comment. Thank you so much for joining. That's awesome. I appreciate you coming in and helping me out here. So as you guys can see, the 4 and the 5 have been inverted. So we need to say we're going to initialize deck D. And we need to offload the values onto the queue. So we're going to pop left until we get to the 4. We just need to swap these two elements. So we initialize the D as a deck. We then will say um, um, how could we do this? So we just need to swap these two numbers. So if we offload using pop left and right onto the queue, the empty queue, we pop off the 1, we pop off the 8, pop off the 2, pop off the 7, pop off the 3, pop off the 6. Now we're left with 4 or 5. We want to swap those elements and then reload back on the values. It's a little trickier. Yeah, exactly, Aaron. He says, happy to help. It can be easy to focus on the programming aspect versus keeping attention to the detail of the question. Right? I just missed over this. I missed over this detail here. But now I'm having trouble identifying how we're going to do this. So let's get the whiteboard out. Let's go to the whiteboard here. Let's clear this off. Okay. So we have some deck D, right, which has these values in it. 1, 2, 2, 3, 4. Sorry, I'm typing with my hand here, guys, on my trackpad. 5, 6, 7, and 8. Okay. We want to get, and we have some empty queue. So if we pop so if we say for every value, if we iterate, say while values in D, we want to, while there's values in D, so we definitely want to say that, like while D, while we have values in D, we want to but we don't want to empty D completely. We want to say while D, the length, while D, while the length of D is greater than 2, meaning that we're going to pop until we get 2 elements remaining in our list. So 4 and 5 happen to be the middle. So we need to say while length of D is greater than 2, we're going to pop left and pop right. D dot pop left and D dot pop right. So we'll save this as left value, and we'll save this. But this, we can't use any other variables besides D, right? So we need to capture this and append it directly to the queue. So this will be queue dot append the left value and queue dot append the right value. So in this first example, we're going to get we're going to append the 1 and we're going to append the 8. We're then going to append the 2 and we're going to append the 7. We're then going to append the 3 and we're going to append the 6. Now our length of our deck is equal to 2. Hmm. This one's tricky. Ah. So, right, and then our deck would be left with just 4 and 5. So then we'll take the deck and say index value 0 and 1. We're going to swap those values. So it would be, well, I'll link to do this, and then deck dot, um, no, deck at index value 0. No, what I don't think we should be popping maybe on the right end. What happens if we just, rather than pop, we just pop left every single time until we get to a value of 4? So we'll pop the 1, we'll pop the 2, we'll pop the 3. Now we got to the 4. If we pop the 4, that makes our 5 stay. So then we can say, 4 value in the range of in Q. This is tricky. Anybody have any thoughts about how we should to kind of push me into the right direction here? I feel like I'm not getting there. I don't want to look at the code. So this one says, if you're looking to achieve the rearrangement, you need to carefully control how elements are moved between D and Q to reorder them. Correct rearranging. So we'll say no code, please. And we'll move the first 3 elements. Okay, so yeah, so if we move the first 3 elements from the D to the Q, that's what it will look like, and those will be removed. Now we have 4 here, so we need to pop right from here. If we pop right, we'll get 5, or we'll get 8, 7, 6, and 5. No, I don't think we want to continually pop the right. So we'll get to the 3, that shuts, and now those are removed. So now we're left with 4 index 0. So the thing is it says that I can only use variables D and Q. So I can't store the popped value in any sort of variable other than inside of the Q. So we're going to, while for range of 3, so we're going to do 3 pops of D. So we're going to say so for something in the range 3, we're going to pop left 3 times. So we'll get the 1, 2, and the 3 off. We're left with the 4. And then, right, we can't store this value for anywhere. We need to move those three elements back from Q to D in the same order. Move the first three elements from D to Q one by one, maintaining their order. Move those three elements back to D in the same order. This preserves the first three elements. Next, take the fourth and fifth element, 4 and 5, from D and temporarily place them in the Q. Oh, okay, so we'll go like this. So we'll take the first three. We'll pop the first three off. We're then going to add them back onto and then we'll say while there's values in Q, we want to do D dot append Q dot pop. Pop left. Like so. So what we'll do is we'll append to D, we'll pop off 1, 2, and 3 from the D list. We'll then reinsert those back into the end of this. We're going to take 4 and 5. Then we're going to say for in range 2, we're going to do Q dot append the D dot pop left, so that'll take the 4 and the 5. So we'll take the pop left here, and then we'll say while Q, we're going to now offload these values with the 5 going first and then the 4. So while we're going to Q dot pop, and then inside of this value that's captured is going to be the dot append to D. So we're not popping left this time, we're popping just a regular pop. And then that'll pop the, so now that what happens is we have D becomes, Q becomes empty. 1, 2, 3 go at the end of the key, end of the deck. And then what we'll do is we'll take the 4 in, take the 5 in, right? And then we'll pop the 5 off, pop the 6, and then we'll do the rest for the next ones. And then say while, or say for in range of, this is, next is going to be 1, 2, 3 values. In the range of 3, we're going to D, or we need to offload 6, 7, and 8 into the Q. So Q dot append D dot pop left in that order. And then we need to offload those values into Q. So while, into D, I mean, while Q, we're going to take 6, 7, and 8 and pop left and append. So Q dot pop left, and then we're going to take this and append this to D, I think. Like so. So now we will go like this, and we'll say return deck D. Okay, so I think that is correct. Hopefully. So, do normal arrays in Python have pop left? No. SD213, the pop left method is specific to this deck import I did from the collections module. The regular pop method is universal for arrays or for lists, general arrays in Python. But the pop left is specific to deck, I believe. So now let's call a print on swap of d underscore 1 and q1. So we don't have a q value established though, or a list. So we need to establish q here as an empty array, right? Or it's going to be a deck, right, with a q. So it's going to be an empty deck as well, which is just, it's a, what was it? What was it called? ADT, sorry, what was it called? It was adapter, right? A simple adapter of the ADT. So what happens if I run this? Come on, fingers crossed. Oh, okay, what do we get? um, we've got a lot of values here. Um, hmm. Q is just a queue, not a deck. Okay, so let's just do Q here as an empty list. And am I doing any pop lefts on the queue? I am doing a pop left on the queue. Can I not do that? Yeah, I can't do a pop left on a non-deck. So we're taking the first three values, 1, 2, and 3, and we're putting them in the queue. We're then offloading those values onto the end of the deck. So I'm gonna draw this out. So the first step is right. It's just kind of a lot of work. So we have a deck D and we have an empty queue. In the range of 3, we're going to Hey Weng Hong, I appreciate you coming in. While D index 0 is not equal for pop left. Okay, so that's a good idea. So let's try this. Let's back up here. I know we did a lot of work here, but let's just back up. Let's say while D at index 0 does not equal the integer of 4, we are going to continually d dot pop left, and then we're going to append these to q. Okay, so right, we append all the way up until we get to 4, and then so 1, 2, and 3 get appended, and then we will say so at this next place we'll say q dot pop the 3, it'll pop the 2 and 1. So it'll be in the reverse order. So the Q though, I can't call pop left on the Q. Right? So this is going to remove 1, 2, and 3 from our list, and we're going to be stuck at 4. So we're going to pop those, and then after we get done having 1, 2, and 3 on our queue, we need to add 1, 2, 3 to the end of our deck here. So okay, yeah, like Legendowski says we can do a pop at index value of 1 or 0. So we'll pop index 0. So we will append the popped value. So let's take 1, put it in, and we can immediately pop that value here. We can just immediately do a pop of that value after we add it in. And then so we'll pop off the 1 and do a d dot append that value of 0. So this is going to, okay, perfect. That's perfect, I think. So we're going to append each of the pops of at each time. So it's going to load one at a time and pop it. 1, boom, pop, 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 over and over, rather than loading all 3 in and then popping 1, 1, 1 at 0. So now we get that. So we have a list of 4, 5, 6, 7, 8, 1, 2, 3, right? At this point. So I'll put a little note here. Our deck equals to 4, 5, 6, 7, 8, 1, 2, 3 at this point. Yeah, Aaron, exactly. Can you do both actions in the same while loop? Perfect, exactly. Hey, Ben2 says, "Hi, Michael. Have you tried using Jupyter Notebooks? You can integrate Markdown with code blocks." No, I've never. I've heard of Juniper Notebooks, but I've never really taken a dive into learning that at all. I've just heard of the name Juniper Notebooks. I'm currently using Markdown as the format for taking my notes here and stuff. So if I don't know, do you guys have any like resources you can point me to that would help, or yeah, whatever makes it easier for people to convey these learnings and stuff in their own way, and to read these notes. I had it originally in TXT files, but so that made it a little bit more complicated. But now this Markdown makes it even easier for non people that aren't me to read it. And so if Jupyter helps, then that would be good. So we'll go out of the while loop. So now we need another loop, right? So now we break out where our D looks like this at this point. We will break out of this while loop and we will say um, so should we say while D does not equal 6? We could say while D at index 0 does not equal to 6, meaning, right, we're going to then do the, for the 4 and the 5, we're not going to pop left. Yeah, we are going to pop left, and then we're just going to pop and append, right? So it will be q dot append d dot pop left, right? And then d dot append q dot pop, right? Not at pop 0. We're going to pop the 5 off first and then the 4 off and append them. Okay, and then we'll say do I have to nest these while loops together like this for them to happen simultaneously or one after the other? Would I need to do that? What do you guys think? Or would this work? So this would hit this, okay, it would produce this D and then move on to this one, right? So this takes 5, 5. Now at this point, our deck looks like this. D is equal to a list of 6, 7, 8, 1, 2, 3, 5, and 4. Okay. So then we'll say while D at index 0 does not equal 1, we're going to do this same function here. So now this should produce us a deck of 1, 2, 3, 5, 4, 6, 7, and 8. So now if we return D here and call this function, fingers crossed, hopefully, I don't know, we'll see. Ooh. So I'm doing a pop left on my list still, where? Where am I doing a pop left on my list? So this is D pop left, D pop left. Huh? Oh. So this is what we get is ah hmm. Tip of the landlord, even with a CS degree, I cannot find a job nowadays. Yeah, that's why I've kind of taken this approach. Is for those that don't know, my name is Michael. I have a degree in human biology and a minor in chemistry. I graduated back in 2021. I work as a formulation chemist for a biotech company for the past 3 years. I'm currently a mid-level scientist too in my profession, and I've been teaching myself Python for the past 6 months just to A, gain some further skills, B, maybe cross intertwine these two fields into one, or even C, maybe even shift fields altogether if certain circumstances arise. But by already having a job and a career outside of CS, it does help take that pressure off and make this just more of a hobby, right? So I kind of I feel bad that it's yeah, it's definitely hard out there. Line 25. Line 25. I'm doing a pop on my queue. So I'm getting this object back in my deck now. So do we need to return? Oh, we might need to. No, we don't want to return. We want to call. Do we need to recursively call again? Oh, there we go. Thank you so much. Pop. Yeah. Okay, so now let's try this. There we go. Okay, we get a deck of 1, 2, 3, 4, 5, 6, 7, 8. Hmm. And we're getting 2 decks here. Why are we getting 2 decks? Hmm. This is tricky. Compare line 20 and 31. Okay, let's try that. 20 appends pop 0. I want to pop the 0 index. Oh, there we go. That makes sense. Okay. So yeah, we're not getting the appropriate swapping though. It's just printing our deck originally. Hmm. What are we doing wrong here? So while the index value at 0 is not equal to 4, we're going to pop left. So 1, 2, and 3 will be popped, and we're going to append those to Q. We are then going to take, at each step, we're going to take okay, that's a good idea. So let's print D here at each step. Okay, so let's see what happens now. Okay, at this step, we take out the 1, we add it to the back. We take out the 2, we add it to the back. We take out the 3, we add it to the back. We take out the 4. Okay, so that's what's going wrong here, is right here. So the 4 is being taken out. Oh, because we're doing it all at once. We don't want to do it all at once. So we want to say while this, we're going to pop, and then we're going to do pop left, append D at here, like that, and print D. So now if we do this, boom, we get the 1 switches, the 2 swaps over, the 4 gets over, this appended the 4. 6, no, that's not it either. Okay, let's think about this. I'm just gonna comment this out so we don't return anything here. I'm just gonna call here like this. So this we get the 1 comes over, so the 4 is being added, so nothing is happening here. So all right, we have some comments here. Thank you guys so much for leaving some chats. I appreciate you guys participating with me here. Line 26, pop is still different. Line 26. So so this is where we obviously are messing up. So we need to focus on this. So we have 4 gets, we are going to do a pop off and append that to Q, which, so the 4 and the 5 are going to be popped off. Then we need to say we don't want to do so append the popped. Sorry that this is taking me a little bit, guys. I'm trying to I'm still learning, wrapping my head around decks and queues and stuff. So these problems are perfect. These are giving us this plug and chug and this thinking. This is exactly what we're wanting for learning through this. So we want to pop left while, and then once we get to 6, we don't want to be appending at this stage. I think we want to move this outside of the loop, right? It'll pop off all of those, and then we will append here and do that. I think that's what we need to do. We need to move this outside of the loop. Okay, so we're close. Now we're getting 1, 2, 3, 4, 5, 6, 7. So now we're just missing the 8. So now take the prints out of the while. Okay, yeah, we'll take them out of the while loop so we can see them after each result. And let's clear here and do boom. So our first one is getting up to 4, 5, 6, 7, 8, 1, 2, 3. Our second one is doing the appropriate swap. And then we're just not appending the 8 at the end. So where's our 8 going? It's remaining in our queue. Why is it remaining in the queue? while D does not equal 1. Because on the 1, we need to pop the 8, right? So we need to call an additional one-time d.append the q pop, right? So this 1, because we have while it doesn't equal 1, well, when it does equal 1, it's not then appending the 8. So we need to do one more append at the end. So this should give us our answer. Woo! Haha! Let's go! Round of applause, you guys. Round of applause. Round of applause. So cool. All right, we got some chats here. Tim, welcome in. Hey, how's it going? Appreciate you coming in. Professor Deming. No, no, no. Definitely not a professor. I'm learning this. This is not a teacher-student dynamic. This is a peer-to-peer. If anything, you guys are teaching me way more, way more. I'm learning this for the first time. I'm not a CS student. I'm a biophysical scientist, a chemist. So this is all new to me, and I appreciate your guys' help. I really, really appreciate you guys helping me out with this. Right? So what happened here was that we got up to the 1, so we didn't actually perform that last pop and append from the 8 in the Q to back into D. So we needed to call one more function here. So now if we just remove these print statements, and then we say let's return D here, and let's call a print on this, and we run, boom. We get our deck is equal to 1, 2, 3, 5, 4, 6, 7, and 8. Ah, so cool. Hey, John R. 1, 2, 3. How you doing? Appreciate you stopping in. Hey, guys. How's it going? Tim says, working on Qs. I see throwback to sophomore data structures. Exactly. We are... where would you guys, in terms of those that are in CS or have graduated from CS, what level would you guys, use your best estimate or best judgment, but what level in terms of collegiate, freshman, sophomore, junior, probably definitely not in that senior role, but what level do you think that I'm currently like representing, or I'm like at, like in between maybe like a freshman and sophomore level? If I like in retrospect and in like relating it to CS majors, like what do you guys think? No, we're not doing bubble sort right now. Currently, we're working on. At the beginning of my streams, I read aloud I read aloud various textbooks to further improve my learning. So right now, we're reading data structures and algorithms in Python. We're on page 273 of 700. I've read all of this book aloud so far, word for word, line by line. So we've read over almost 300 pages aloud, audiobook style on the stream. We've broken down, complex jargon in the text and examples using AI and stuff. We have, ChatGPT to help us out, but we obviously preface it to not show us any code. That's one of my key things is I really like to make it not show me code unless I really, really, really am stuck. But even if I'm really stuck, I'll use you guys and other resources before I'll look at code. So I'll use it to help break down, verbal jargon and kind of stuff like that and more complex topics, give me better examples than the book gave. But then what we do is we do the practice problems at the end of the chapters. And then in my streams where I have a little bit longer format, for those that are new, I'm currently visiting my family on the holiday break here just for one more day. I'll be back in my normal setup tomorrow at my desk. But so when I do my longer streams, we do this learning at the beginning, and then we actually implement into projects that we're working on, such as this small business manager project that we've been building for the past few weeks. So we got a lot of progress done on this. We have over almost 500, almost 600 lines of code so far in this one project. So it's coming along really nicely. It's just kind of like a business manager, inventory, expenses, generating reports, hopefully, for cost of goods, income statements, revenue, all that kind of stuff. Just to be a more, just to help out small business owners, really, would be kind of cool. All right. First year, like second semester. Okay. That sounds probably about right. First year, second semester. Cool. We've only been going about 6 months, so that's pretty good. That's pretty good with me. All right. All right, that was that problem. Um, So if this is a format you really guys like, interacting with me, please follow along. We just passed over 600 subscribers yesterday, so huge milestone, and we're continually growing every day. We get new subs just out of the blue every day, and it's super awesome. You guys are finding these resources helpful. For those, also, I have these books and all these PDFs and my notes and everything on my GitHub, and also all the books and stuff are in my Discord linked below in the description, where I've just compiled all of my study resources into one location for you guys to also gain access to and follow along and study in your own ways. So if you guys want access to all that, please join below in the Discord as well. In 2025, Harvard CS50 is going to be revamping their X course, or their full stack computer science course, and we are going to be taking that January 1st, 2025. We're going to be starting that up. So I'm going to be posting some announcements, like watch party announcements and announcements for when I'll be hosting those, watches on my stream for the CS50X specifically. Those will be apart from our normal streams probably. So it'd be a lot more work for me, but it's going to be fun nonetheless. And hopefully my goal is to complete it in about a month and a half, maximum 2 months. So I'm pretty sure we could do it in a month or a month and a half. Um, Joe R123, you need to teach yourself some maths too. Why not do discrete maths? Yeah. So I in my current math, I've taken up to and through calculus 1, but I will preface that I took calculus 1 my freshman year of college. I was fairly advanced in my mathematics coming up through elementary and high school and stuff. So I was able to take calculus 1 my freshman year of college. Um, and that was all of my major required, though. I did end up taking a statistics course, like a 3,000 level statistics course, my junior year, which helped with like p-values, significance values, normal curves, bell curve, all that kind of stuff. But I honestly don't remember a lot from that. I'm a chemist, so I mainly focus on the chemistry. I worked as a lab instructor for the chemistry department. I worked with the graduate students as a lab instructor, even though I was an undergraduate. It was I kind of finagled my way into that, and then I was also the undergraduate teaching fellow for the chemistry department, and so I hosted all the review sessions for the studying and the tests and the final reviews and all that stuff. So it was really a good experience, but like it kind of beside the point. I focused mainly on that chemistry in my school. Looking back, I wish I would have really tried more in math and kept going, because it would have helped a lot. You can go into discrete math with that knowledge. Yeah, so funny enough, I started the 6.042J course, which is the discrete mathematics, or the mathematics for computer science offered by MIT. I did a single watch along episode on my channel as a video, but when I went to go watch week number 2, I was just like, uh, it took me like an hour to get through the first 15 minutes. And I was like, how am I going to edit this down? It just was like, I just didn't think I was quite there yet. I was understanding what they were talking about with their proofs, but it just took me a while to follow their logic. Like when they would start from a proposition and then they would give all of their justifications in their proof, I would get there, but it just took me like 10 times longer than what the other students in the class. So they were moving on so fast. And yeah, I'm retired from MIT. So I did one episode, one lecture, and I haven't started again. I definitely need to go back and continue that. But it was just really difficult. And it really bewildered me that none of these students asked any questions. Like, they have to be just really smart. They're MIT students, right? So they have to be just really smart and know this stuff already. But no one asked any questions along the way. So like there was no further discussion, clarifications. It was just boom, 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 topic, 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 and it was pretty difficult to follow. Bon Bon says, "What is the difference between a stack and a heap?" I'm not sure what a heap is. We haven't got there yet. We're on chapter 6, which is stacks, queues, and decks. We understood. So I'll just quickly again, I'm learning this, so take this with a grain of salt. I'm teaching myself this through these resources. So if I say something incorrect, please correct me or solidify what I'm saying. But from what my understanding is, think of like a stack as like a stack of pancakes, a stack of CDs, where you organically cannot take from the middle or the bottom or anywhere else but topmost element. If you were to try to take from the bottom CD, it would cause like a Jenga effect and cause the tower to fall over. So the stack, you can only remove elements from the topmost portion or the most recently added, a last in, first out principle. A queue was similar to that of a line, like a line for an amusement park, or or for whatever, where the first person in is the first person out. Where you get in the line, you wait your turn, and then you come up to the front, and then you're removed from the line. A deck was similar to a queue, but it was a double-ended queue, meaning that you could remove at both ends. So think of also an amusement park line, but if it's really long and people don't want to wait anymore, they're like, oh, this is annoying. Like, I don't want to, I'm sitting at the back, I'm done. So they can then leave, right? They have the option to leave the line. So those are the kind of examples we were looking at. And then in chapter 5, the previous chapter was all about array-based sequences. So this just introduced the memory aspect of arrays, differentiated arrays and lists, and how lists were kind of match similar properties of arrays, but arrays had more of that, have a homogeneous elements. Like lists can have just a list of any arbitrary types, whereas arrays are all the same elements. You have memory management, like manual memory management is continuous in memory. The references and the objects are saved elsewhere in the arrays, in the memory, but the array itself just has placeholders for elements to be put in, and that's what determines the overall size. It's not the actual elements in the array, which is a really key concept. Um, yeah, so that's just kind of a general review about those two. So sorry about my yapping here. Joe R says that is a very exhaustive approach. LOL. There are YouTube playlists out there for discrete math. You should check them out. The thing you can name many times when they're sitting in lectures. Name many times when you were sitting in lectures and no one asked questions to the teachers. So when they recorded these videos, no one wants to ask questions. You could. The thing is, you could name many times when you were sitting in lectures and no one asked questions to the teachers. So when no one wants. Okay, yeah. I have like a different philosophy at my work and stuff. I really don't care if I'm the annoying guy that asks a lot of questions, because I want to perform at my most optimal ability. And so I have no shame in asking questions, even if it's a dumb question in the person's mind, because at the end of the day, I don't care what that person thinks of me. I care if I'm learning the material. So, um, if I was in those students' shoes, I would have just been rapid fire asking away. Me and the teacher would have been having a one-on-one discussion the entire class. Like I honestly, I have no shame. Like at my work, like I will constantly keep asking until I get it right, because I want to be performing and producing products that are, optimal and up to standards, and I don't want to sell myself short. So maybe like if you guys have a similar approach, yeah. People might ask fewer questions if there is a camera. Yeah. Okay, you guys. We did. Where are we here? What? 6.13. Repeat the previous problem from the deck D and initially empty stack S. Okay, so now we're going to use it with a stack rather than a queue. Hmm. I'm curious though, you guys, because this is a queue, an empty queue, meaning that we can only remove elements from the front, can we not do this? Can we not do a queue.pop? We can do this, right? Queue.pop 0, but because this queue is not a double-ended queue. This is not a deck, it's a queue. So can we not technically pop out the end of a queue? Because that would give it the same principles of a double-ended queue. Hmm. What do you guys think about that? So I do have to wrap things up at about 5:30, you guys, which is about 6 minutes. Um, I'm going to a basketball game tonight. For those that don't know, I'm just here on vacation visiting my family for the Christmas break holidays. I'm going back tomorrow to my normal setup where I stream, 2.5 to 3.5 hours every day. These just for the past couple of days, I've just been doing a little bit of a shorter format just because I've been trying to spend time with my family while I'm here. But I wanted to still stream to you guys and do this learning and keep things going and moving along here for the channel and my learning. So, sorry, I'm stuttering all over the place. But we will tackle this 6.14 next time. But it's interesting. What do you guys think about this pop? Right, this pop on the queue. Because technically, this queue is just a list. Right? And with a queue, you cannot do a dot pop, right? But instead a pop index 0. That's correct. In Python, a queue typically means using a data structure where items are processed in a first in, first out order. If you're using a list as a queue, you cannot directly use pop without arguments for FIFO behavior because pop removes. Joa says, let's just say you complete the DSA book. What's the next area of CS you're going to endeavor? That's a good question. I currently have a couple more books on my actual physical books I bought that we're going to read. Hopefully, I have the Fluent Python book to further just re-solidify even more advanced topics into Python itself. My principle is I really want to master a language before I kind of focus on spreading out and acquiring other language knowledge because I feel like the current trend is that people gain knowledge, a general knowledge in many languages, but don't actually know, have an efficient mastery in a single one. So I'm trying to take the inverse approach and really master one before I move on to other ones. What school did you go to? The school I graduated from Utah State University. I had an alumni deal. My mom played sports there for some scholarships, and so I was able to get waived out of state tuition and things like that because I'm from Oregon and stuff like that. But yeah, so it just ended up working out, and I had a good time at Utah State. It was fun. Yeah, so I have Fluent Python. I also have machine learning in Python that we will get to as well. But my next course, like I said, in 2025, Harvard CS50X is going to be releasing a new revised version of their course. So we are going to be taking that and doing a live, work through of that course on the stream. So if you guys are interested in that and want to take that alongside me, please follow along and join the Discord below while I'll be providing announcements and more information about when we're going to be starting that up. Marcus says, "Oh wow, I go to UVU. Awesome! I had a lot of family and friends that went there as well." I already graduated back in 2021. I graduated with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company in the Bay Area, and I have been doing that for the past 3 years since I graduated. I got a job right after, like a month after I graduated. In 2021, the market was really good, fortunately for me, and during that time, I kind of jumped in right there before the everything went crazy for jobs and started going downhill. I got really lucky in that front. But I work as a chemist, and for the past 6 months, I've been teaching myself out of books and various resources programming in Python from scratch. I never had seen a line of code before 6 months ago, and look at us now. We're writing complete functions and data structures and algorithms. So it's really cool that we're actually improving, and this is proving to be a worthwhile endeavor here. What is CS50X? How many lectures? I think it's like a 10-week program. So there's 10 lectures and 10 problem sets and one final project or something like that. Are you going to do videos at the end where you review the books and maybe some pros and cons? That would be actually a really good. I never actually thought of that, Pro Doc. That's a really good idea. Maybe I'll have to do a review of Python Crash Course and do like a final, like, should you read this? Is it like a final suggestion and overview? Yeah, that's a really good idea. I will do that. That's an awesome suggestion. Um, so I wonder though, with this problem, right, we might have to revise this in our next stream because we're calling a pop on a queue and that is not appropriate in my opinion from what we've been taught about cues. So we have to come out with a different approach here, um, which is interesting because the almighty orb kind of guided me down this process. So, which yeah, it's interesting. I mean, our cue in Python technically resembles a double-ended queue, right? Like in terms of its like what was it called? It's adapter, ADT, abstract data type, whatever. Um, Marcus says, "Have you covered binary trees, linked lists, and graphs already?" No. So just perfect that you say that. Our next chapter is linked lists. So chapters so chapter let's see here, chapter 1 and 2 were just Python. Chapter 1 was Python review. Chapter 2 was all about Python classes and object oriented, so just more review. Chapter 3 jumped into time complexity, big O, big theta, big omega, time complexity, the 7 functions of determining time complexities: constant time, linear time, logarithmic time, n log n, exponential, quadratic, cubic, all those functions. So we did a lot of review there. Chapter 4 jumped into recursion. So that one was probably the hardest chapter for me so far. Wrapping my head around recursion. I still am doing practice problems every so often just to keep practicing recursion. And I still am interested in keep going and learning about recursion. That one was definitely more of a tricky concept. Probably one of the harder ones I've had to learn. Object-oriented programming and recursion were probably the two hardest concepts I've had to learn so far and wrap my head around. When I first learned OOP, I just was like, how are you creating objects in code? I was like, what does this mean? But I finally kind of wrapped my head around it, which is really cool. And then chapter 5 jumped into, like I said earlier, into arrays and data structures, and then chapter 6 was all about queues, stacks, and decks. So chapter 7 will jump into linked lists and then into graphs, and from so this is a perfect place to be if you're wanting to really dive into the nitty gritty here. We're really starting to get into DSA here. And this PDF is the data structures and algorithms in Python. It's by 3 authors. One is named, I think it's Michael Guyes or something like that. I'm sorry, I can't pronounce it has the same first name as me, as one of their primary authors. But I also provide a copy of all of the notes and the resources I'm using down below in my Discord. So please join that, completely free. I'm a student of this. I'm learning. I would never charge for something that I'm not, I'm learning this. And so, yeah. I appreciate you guys joining me. But I actually have to head out for today. Like I said, I normally stream for about 2.5 to 3.5 hours every day after my 9 to 5 job, but I'm just visiting my family here on Christmas break, just on over the holiday break here. I will be back in my normal setup tomorrow, where tomorrow evening we will do an entire 2.5 hour, 3 hour stream. We'll finish chapter 6, move on to chapter 7, and then jump back into our projects, right? We want to implement this learning into actual projects that we're doing. So right now we're writing a small business manager project, which takes in, saves and writes files for various object-oriented items for inventory. We are going to transact these items into for sale and sold items, thus giving them charges for currency. And then we're going to ultimately generate reports for these businesses and these small businesses that are using this program to give them income statements, cost of goods statements, revenue statements, expense reports, all that kind of stuff will be associated. So we're slowly chipping away at this project in the back half of our normal streams. But I appreciate you guys joining me for today. Yeah, I'm going to be going to a basketball game. Just one last little fun thing before I get back into reality, back going to work next week. So it's going to be fun here. Yeah, I have no problem. You guys, whatever you want, and as long as it's cordial and keep everything cordial and chill on the server, you can promote yourself. But just try to keep it focused on programming. That's the whole aspect of it. As long as you're promoting programming, that's what the key concept of the server is. Nice. You should try C/C++ after you master Python to get experience in both low level concepts. Yeah, exactly. We had a lot of people, current CS and past CS majors, that have joined the channel and joined the community here have been suggesting, Mike, you need to take a stab at C and C++ sometime. It'll really help you solidify these Python concepts and even improve your Python knowledge. So I think in the Harvard CS50X course, they're going to give us more of a deep dive into that low-level programming, C, C++, memory management stuff. So come 2025, in just a few days when they revamp that course and we start it up, we're going to get experience with all that kind of stuff. And then hopefully I'm going to pick up a book on C and C++, and we're going to work through that book next too. So yeah, we have a lot of stuff coming, so please follow along. We have a lot of learning coming, and this is a great way to solidify your knowledge and study along in a more or less of a more of a not carefree, but a less stressful environment, right? We're not grinding for jobs right now. This is like we're back in school. You and I are in a study room in the library, and we're working this through together. And it's a friendly environment, peer to peer. That's what I really wanted this to be, and I'm getting a lot of feedback on it, and everybody seems to be enjoying it so far. So it's really awesome. I usually code in Jupyter Notebooks for Python, which I find easier, but I wanted to try Visual Studio. Do you have any tips on how to use it? I've been struggling. Um, it's fairly intuitive in my opinion. Like once you just learn like all these menus and like what extensions are and stuff, these are the extensions I'm using if you want to take a look at them. I have Black Formatter. This is for live server. When I started the Odin project course a few months back, I haven't done any more of that Odin project course. Got about halfway through it. We have Prettier Code Formatter, Pylance, Python Debugger. We use Rainbow CSV because I do use CSV in my projects. And then we have VS Code icons for these icons here within the file menu. So VS Code is just very intuitive and it's very user friendly. So just keep practicing with it, and I think you'll get it. Maybe a couple video tutorials online could help you, but I think just practice makes perfect with it. Just actually using the program because there's not really too many super advanced like it's not like Photoshop or Adobe Illustrator where they add in some sort of deep hidden element that you have to go searching for to get a certain effect or something. You can also go to like the settings and literally just like search any setting in the settings menu. So it's really cool like that too. I started with PyCharm, and I wrote like a couple. I started learning with that, and then I shifted over to this because it seemed like more what everybody was using just online and more tutorial based. Yeah. Yeah, you can post the link in it, like in any of the community tabs or whatever language it's associated with Script Serpent. So if it's Python, maybe the Python community, or just throw it maybe in the off topic, whatever. That's just kind of like the more default for like anything, more of like a garbage collection for all just kind of off topic stuff. We have a new scenario. No, no, ASCII. I'm just visiting my folks here on a winter break. No, no, nothing, nothing crazy. No, just visiting my folks here. That's why we're in a different setting here. All right, just getting caught up on the last couple of chats before I send off. I'm sorry, you guys. Um, do you have any goals with learning Python or with programming in general? So, like I said, I am a chemist. I do have a 9 to 5 job already. So, I would really like to incorporate Python into my current work. I do a lot of matrix work where I have to look at a lot of different variables or rows and columns in a matrix for various solutions and combine them to and predict their their concentrations or their theoretical concentration values or effective concentration values within the actual lab and what we would actually see based on my predetermined and preliminary testing of those serums. So I have to do that very intuitively, and it takes me quite a while to mathematically do it all by hand. So using Excel, obviously, but by hand in theory. So if I hopefully would maybe develop a program that could do that for me would be really cool. But we need to understand more about data structures and algorithms to create that algorithm and have it be fast is the key principle. So that's why we're doing this as well. But like I said, I'm also not limiting myself to any sort of potential fields or interests. Or like whatever door opens with the skills that I'm requiring, I will just take that when I get there. I'm not putting too much pressure on this learning. I want to treat this as a hobby because I think that this is really fun. And when you start to kind of put pressure on it, like, oh, I need to get a job, I need to do this, you're starting to force yourself to code, and then you might lose enjoyment. So I'm really trying to remove that, keep this as a hobby in theory, and because I really enjoy doing this, and the stream just further levels that up and makes it even more enjoyable. How is the job market looking for chemists now? Yeah, it is pretty rough as well. I will say that it seems like biotech and tech are kind of also in the same situation where I think a lot of the funding in COVID, inflated the job market and provided a lot of jobs that maybe weren't needed, and and we're currently seeing some repercussions of that, and people are getting cut, unfortunately, and there's just less positions. It's more competitive. I think a lot of the biotech and tech companies are getting less funding as well, like from the government. They're not getting that subsidizing from the COVID era, so they're cutting back on their budgets, and that's reducing salaries and reducing roles. So just increasing it's just tough all around. So I luckily got into the chemistry field and my job at the very end of 2021, beginning of 2022. So I just got in before that whole kind of job market just really started to fall. This is a VS Code. This is by Microsoft. This is the ID, VS Code, Visual Studio Code. It's also what they model off of for the CS50 courses. They have their own live server online, which just models the VS Code format. So that's why I also have used it. All right, you guys, I have to head off. I'm gonna go to a basketball game, an NBA game. It's gonna be really fun. I'm super looking forward to that. So I'll see you guys tomorrow. Please follow along. Please join the Discord. Subscribe. Like the video if you enjoyed spending some time with me. It really helps to get other people to also see and get suggested the videos, and just also helps motivate me and keep me going. And it's great to interact with you guys. I really appreciate it. I'll be back tomorrow in my normal setup, and we'll do a normal 2.5 hour, 3.5 hour stream, going over the remaining bits of Python of chapter 6 in data structures and algorithms, and then we'll jump into linked list in chapter 7, and then we will dive into our actual project here. So I will talk to you guys later. I will see you. Thanks so much for joining me. I'll see you guys tomorrow.